Your car isn't dying from wear and tear, it's dying from the advice you trusted. Those maintenance schedules in your owner's manual, they're designed to move inventory, not protect your investment. That's exactly why some engines quit at 100,000 miles while others cruise past 600,000 without a rebuild. The difference isn't the car, it's the habits. I'll show you 16 proven secrets that can push any vehicle beyond 500,000 miles without major repairs. These aren't dealer recommendations, they're real-world strategies that actually work. This exposes the biggest transmission lie in automotive history. That lifetime fluid promise isn't protecting your transmission, it's protecting manufacturer warranty costs. They know most people trade cars before major failures hit, so they market maintenance-free transmissions to boost sales appeal. Here's what actually happens inside your transmission while you trust that lifetime claim. Every shift sheds tiny metal bits. If fluid breaks down, those particles grind the transmission. The hydraulic properties that keep your transmission shifting smoothly start degrading around 80,000 miles, even though the fluid still looks clean and red. Your transmission doesn't announce its death. The internal damage accumulates silently. Clutch plates wear faster, valve bodies collect debris, solenoids start sticking. By the time you feel that first slip or harsh shift, the internal damage already exceeds repair costs. A complete transmission rebuild runs $4,000 minimum. Compare that to a modest drain and fill service every 60,000 miles using proper OEM specification fluid. Hybrids can stretch toward 90,000 miles, but no more. Always choose drain and fill over aggressive flushing if the fluid has never been changed. Use OEM spec fluid. Mixing in universal ATF risks slipping and overheating. Toyota WS for Toyota, Honda ATF DW1 for Honda. This single maintenance habit eliminates the most expensive automatic transmission failures. Your transmission will shift smoothly past 300,000 miles, while others die following manufacturer recommendations. But transmission fluid isn't the only maintenance lie designed to move inventory instead of protecting engines. This habit reveals why factory oil change intervals kill engines slowly. Your owner's manual recommends 10,000-mile intervals, but that schedule prioritizes showroom appeal over engine protection. Automakers stretch these intervals to make vehicles appear low maintenance during the buying process. Marketing departments know buyers compare maintenance costs between brands. A car requiring oil changes every 3,000 miles looks expensive next to one claiming 10,000-mile intervals. The real agenda focuses on initial sales, not long-term reliability. Don't treat factory intervals as gospel. Follow correct fluid specs, but consider shorter intervals based on real-world use. Inside your engine, extended intervals create invisible destruction. Oil molecules break down under heat and pressure. Carbon deposits form on intake valves. Sludge accumulates in oil passages, restricting flow to critical components. Variable valve timing systems fail when contaminated oil clogs the tiny passages that control timing adjustments. Timing chains stretch prematurely when dirty oil loses its lubricating properties. Cam phasers seize up completely, triggering expensive repairs that could exceed your car's value. Experts often recommend 3,000 to 5,000 miles for many cars, especially if you do short trips, tow, or drive in dusty conditions. Use the oil weight and type the manufacturer specifies, but favor quality synthetic in newer engines when applicable, and always replace the filter with each oil change. Check your oil color and level today. If it's very dark or low, schedule an oil change sooner. Speaking of filters, there's another component that works alongside your oil but gets completely ignored. This focuses on your oil filter, the critical barrier between clean oil and engine destruction. Your oil filter isn't just a nice addition to oil changes, it's the final defense against contamination that kills engines prematurely. Avoid bargain bin filters. Use OEM or high-quality aftermarket filters with proper anti-drainback and multi-layer media. Cheap filters use inferior media that can't handle normal oil flow under pressure. When they clog up with contaminants, they automatically bypass dirty oil straight back into your engine, while inferior anti-drainback valves let oil drain from the filter overnight, causing dry startups. Quality OEM filters cost more because they use multi-layered filtration media designed for your specific engine's oil flow requirements. because they use multi-layered filtration media designed for your specific engine's oil flow requirements. The pleated paper holds more debris before bypassing. The anti-drainback valve prevents oil from draining out of the filter when the engine sits overnight. When inferior filters fail, they create contamination cycles that accelerate engine wear exponentially. Metal particles recirculate through the system, creating more metal particles. This cycle destroys engines that could otherwise run 400,000 miles. Always replace the oil filter every oil change with an OEM or trusted brand filter. No exceptions. This single habit eliminates the contamination cycles that kill high-mileage engines. But oil isn't the only fluid that transforms from protector to destroyer over time. This habit exposes the coolant system deception that destroys engines silently. Your coolant looks crystal clear and feels perfectly fine, but aging coolant becomes your engine's worst enemy. Most drivers check coolant levels, but never question what's happening chemically inside that fluid. Fresh coolant protects metal surfaces with alkaline additives that neutralize acids. Over time, these protective additives deplete while combustion byproducts seep past head gaskets. Your coolant gradually transforms from protector to destroyer as it becomes increasingly acidic, attacking water pumps, seals, heater cores, and head gaskets from the inside. Acidic coolant attacks aluminum heads, corrodes steel engine blocks, and eats through gasket materials. The process happens invisibly while you drive. Metal ions dissolve into the coolant, creating electrolytic corrosion that weakens critical sealing surfaces. If you smell sweet fumes, see white smoke, or the reservoir keeps dropping, don't just top off. Get a coolant flush and inspection. By the time you notice these symptoms, internal damage already compromises head gasket integrity. Regular coolant flushes every 3 to 5 years using exact manufacturer specifications prevent this chemical transformation. Use only the manufacturer-specified coolant. Do not mix colors or types. If in doubt, replace the coolant with the exact type your manual specifies, rather than topping off with whatever's in the shop. This preventive maintenance eliminates catastrophic head gasket failures that can cost more than your vehicle's worth. But coolant isn't the only system where a small, inexpensive component controls your engine's survival. This reveals how a $15 part can strangle even the most powerful engines. Your air filter does more than block dirt particles. It regulates the precise air-fuel mixture that determines whether your engine runs efficiently or struggles for every breath. Most drivers wait until their air filter looks completely clogged before replacing it. This approach forces your engine to work harder just to pull air through the restricted media. Inspect your air filter at every oil change and replace it before it becomes fully clogged, especially if you drive in dusty conditions, off-road, or heavy city traffic. Dirty filters create problems throughout the engine system. Reduced airflow means less power output and increased fuel consumption. Contaminated air reaches sensitive mass airflow sensors, causing them to send incorrect readings to the engine computer. These false readings trigger poor fuel mixture decisions that waste gas and create rough idle conditions. Replace the air filter regularly, and if you use oiled aftermarket filters, check and clean the MAF more often. Clean the MAF sensor with proper MAF cleaner every 12,000 to 15,000 miles to restore performance and avoid expensive sensor replacement. Watch for symptoms like loss of power, rough idle, worse MPG, or check engine codes P0101 and P0104. Your engine needs unrestricted air to run efficiently. Keep the intake path clean. But there's another component you check regularly without understanding its true impact on your vehicle's health. This habit exposes tire pressure as the foundation that controls your entire vehicle's mechanical health. You walk around your car, glance at the tires, maybe give one a kick, and assume everything's fine. That quick visual check misses the precision your vehicle demands for proper operation. Tire pressure affects far more than gas mileage numbers. Underinflated tires create excessive sidewall flexing that generates heat and irregular wear patterns. This flexing forces your suspension components to work harder, compensating for improper tire geometry. Ball joints, control arm bushings, and shock absorbers wear faster when tires can't maintain their designed contact patch with the road. Improper pressure also throws off wheel alignment angles. Your alignment specifications assume correct tire pressure. When pressure drops, the tire's shape changes, altering the suspension geometry and creating uneven tire wear that destroys expensive tires prematurely. Look for feathered wear, cupping, or odd edge wear. Those mean alignment or pressure issues. The compounding costs add up quickly. New tires every 30,000 miles instead of 60,000. Suspension repairs years ahead of schedule. Check pressures weekly and before long trips. Set pressures to the door jamb placard, not the tire side wall. Weekly pressure checks with seasonal temperature adjustments prevent this cascade of expensive failures. Proper tire pressure supports alignment geometry and, combined with regular tire rotation, protects your tires and suspension from premature failure. But even perfect tire pressure can't protect your engine if one tiny component starts failing inside the combustion chamber. This centers on the small component that decides whether your engine purrs smoothly or tears itself apart from within. Your spark plugs create the controlled explosions that power every mile you drive. When these plugs start degrading, they trigger a destructive chain reaction throughout your entire engine system. Worn spark plugs don't just create weak sparks that cause misfires, they create incomplete combustion that sends unburned fuel directly into your exhaust system. This raw fuel ignites inside your catalytic converter, creating extreme temperatures that melt the internal honeycomb structure. Your converter transforms from emission control device into expensive scrap metal. Replace quality spark plugs every 60,000 to 70,000 miles, depending on engine type. Turbo and direct injection engines need attention sooner. For many Japanese cars, NGK Iridium or Denso Iridium TT work well. European cars often do better with Bosch Double Iridium. Ford and GM vehicles typically run best on OEM plugs like Motorcraft or AC Delco. These are mechanic-recommended starting points, not absolute rules. If a plug tip is wet with oil or coolant, that's a sign of a leak. Don't just replace the plug, find the source. Fresh plugs prevent misfires that trash cats and sensors. Cheap plugs, expensive consequences. But even perfect ignition can't protect your engine when contaminated fuel attacks the system from within. This habit confronts the reality that modern fuel isn't what it used to be. Your fuel system battles contamination from sources you'd never consider. Water accumulates in underground storage tanks. Ethanol blends attract moisture from humid air. Fuel additives break down over time, leaving residue that clogs precision components. These contaminants accumulate gradually in your fuel system, creating hesitation, misfires, stalling under load, and poor fuel economy. Injector nozzles develop varnish buildup that disrupts spray patterns. Fuel pumps work harder, pushing fuel through restricted filters. Carbon deposits form on intake valves, reducing engine efficiency. Replace fuel filters every 30,000 to 60,000 miles, and sooner if you tow, drive in dusty areas, or run lower quality fuel. Use OEM or trusted brand filters like Bosch, Motorcraft, or AC Delco. Replace the filter completely, don't just blow it out, as that leaves contaminants behind. Quality fuel combined with targeted cleaning additives provides active protection against these issues. Top-tier gasoline contains superior detergent packages that prevent deposit formation. Fuel system cleaners remove existing buildup before it causes performance problems. Proactive cleaning prevents the expensive reactive repairs that follow neglect. Clean fuel systems ensure proper injector function and fuel pump longevity well beyond 200,000 miles. But there's another fluid in your vehicle where contamination creates life-threatening consequences. This targets the brake fluid characteristic that determines whether you stop safely or crash into whatever's ahead. Your brake fluid absorbs moisture from the air through microscopic pores in rubber hoses and seals. This hygroscopic property seems harmless until you need maximum braking power. Water contamination creates deadly consequences inside your brake system. Fresh DOT3 brake fluid boils around 401 degrees Fahrenheit, while DOT4 boils around 446 degrees. Just 3% water contamination drops that boiling point into the low 280s. During hard braking, brake fluid temperatures spike beyond this reduced threshold. When contaminated brake fluid boils, it creates vapor bubbles inside your brake lines. These gas bubbles compress under pressure instead of transmitting hydraulic force to your brake calipers. Your brake pedal sinks to the floor while your car continues rolling toward impact. Vapor lock strikes without warning during the exact moment you need stopping power most. Emergency stops generate the heat that triggers vapor lock conditions. Mountain driving, heavy loads, or repeated hard braking push brake fluid temperatures past the danger zone. Buy a $20 brake fluid tester and flush if moisture reads over 3%. Test the fluid and flush every 2 to 3 years. When in doubt, flush and use the specified DOT fluid. But brake fluid isn't the only component that fails silently until catastrophic damage strikes. This habit exposes the belt that destroys engines without warning. Your timing belt operates in complete silence until the moment it snaps and turns your engine into expensive scrap metal. Most drivers never think about this rubber belt until catastrophic failure occurs. Timing belts age even in low-mileage vehicles sitting in garages. Heat cycling from engine warm-up and cool-down creates microscopic cracks in the rubber. Oil leaks from valve covers contaminate the belt material, causing it to stretch and weaken. Time itself becomes the enemy as rubber compounds deteriorate, regardless of actual mileage. Have timing belts inspected by 60,000 miles and consider replacement earlier than the owner's manual suggests if belts show cracking, glazing, or oil contamination. Interference engines create the worst-case scenario where pistons crash into open valves at thousands of RPMs, destroying pistons, bending valves, and cracking cylinder heads. Hidden factors accelerate timing belt failure beyond manufacturer schedules. Extreme temperature swings, oil contamination from leaking gaskets, and tensioner bearing wear all reduce belt life significantly. These conditions exist in every engine, regardless of maintenance quality. When replacing a timing belt, replace the tensioner, idler pulley, and water pump at the same time because they wear together. Proactive replacement prevents the most expensive engine repairs and ensures engine longevity past 300,000 miles. But mechanical components aren't the only systems that fail without obvious symptoms. This reveals how electrical problems disguise themselves as engine failures. Your mechanic runs diagnostics on what seems like a fuel injection issue, but the real culprit is a corroded battery terminal creating voltage fluctuations throughout the system. Modern engines depend on precise electrical signals to operate properly. Battery voltage drops affect oxygen sensor readings, mass airflow sensor accuracy, and fuel injector timing. These sensors send false data to the engine computer, triggering incorrect fuel mixture calculations and ignition timing adjustments. Poor electrical connections create the most expensive diagnostic nightmares in automotive repair. A loose ground wire generates random error codes that point to multiple system failures. Watch for slow cranking, flickering lights, or random codes. These often trace back to bad connections. Mechanics replace expensive components, chasing phantom problems, while the real issue remains a 50-cent connection. Check battery terminals every few months and clean corrosion with baking soda and water paste. Scrub with a toothbrush, rinse, dry completely, then coat terminals with dielectric grease or petroleum jelly. Test the battery and replace weak batteries before they create accessory or sensor faults. Cleaning a terminal solves many mystery errors and saves you from expensive, unnecessary parts replacements. Clean electrical connections ensure accurate sensor readings and proper computer operation past 400,000 miles. But electrical systems aren't the only forgotten components that can leave you stranded with massive repair bills. This habit focuses on the drivetrain components hiding under your car that most drivers forget exist until they leave you stranded. Your differential and transfer case handle extreme torque loads every time you accelerate, turn corners, or navigate different road surfaces. These gearboxes operate under pressures that would destroy most mechanical components. Inside these housings, gear oil endures punishment from massive ring and pinion gears grinding against each other thousands of times per mile. Metal particles shave off gear teeth and accumulate in the oil. Heat from friction breaks down the oil's protective properties, while contamination turns lubricant into grinding paste. The gear oil that once protected these expensive components becomes the agent of their destruction. Ring and pinion wear accelerates, bearing surfaces score and pit, The differential starts whining during turns, then vibrating under load. Complete lockup follows when metal debris finally jams the gear mechanism. You're looking at differential rebuilds exceeding $4,000, plus towing costs from wherever it fails. Change differential and transfer case oil every 30,000 to 50,000 miles, if towing or heavy use. For normal driving, follow the manual but err on the side of earlier changes. Warm the car with a short drive to thin fluid, remove the fill plug first, then the drain, wipe magnetic drain plug clean, and refill with exact spec gear oil until it starts dripping from the fill hole. Fresh gear oil removes metal contamination before it grinds bearings and gears. But gearboxes aren't the only system where fluid breakdown creates control problems and expensive repairs. This exposes the fluid that makes steering effortless, but gets ignored until expensive components fail. Your power steering system operates under pressures exceeding 1,000 psi every time you turn the wheel. This hydraulic fluid endures extreme stress while lubricating precision components that cost thousands to replace. Power steering pumps, racks, and hoses depend on clean fluid to operate smoothly. Over time, this fluid breaks down from heat and pressure, and contaminated fluid becomes abrasive and accelerates pump and rack wear. What once protected these components transforms into grinding paste that destroys them from within. Contaminated power steering fluid creates early warning signs most drivers ignore. Watch for whining noises when turning, steering stiffness, or erratic steering response. These symptoms appear long before complete failure, giving you time to act before expensive repairs become necessary. Follow the manufacturer's interval, but replace sooner if the fluid looks dark or foamy, or if you hear pump whine. If your use is severe, towing, heavy steering loads, frequent parking lot turns, change the fluid more frequently than the manual suggests. Fresh fluid removes contaminants before permanent damage occurs and keeps steering systems operating smoothly past 250,000 miles. But steering fluid isn't the only filter system that protects expensive components from contamination and premature failure. This habit targets the cabin air filter that protects more than your breathing comfort. Your cabin air filter sits between outside air and your HVAC system, but most drivers only think about it when the air smells musty. This filter actually determines whether your climate control components survive or fail prematurely. Clogged cabin filters force the blower to draw more current, risk burning the blower motor, and let dirt reach the evaporator, causing mold and efficiency loss. The motor draws more current, fighting increased resistance. Over time, this extra load burns out blower motor windings that cost hundreds to replace. Contaminated filters also allow dirt and debris to reach your evaporator coils. These delicate fins collect the particles that passed through your failing filter. Dirty evaporator coils reduce cooling efficiency and create breeding grounds for mold and bacteria. The restriction from clogged filters reduces airflow throughout your HVAC system. Your air conditioning compressor works harder to achieve the same cooling effect. Heater cores struggle to warm the cabin through restricted airflow. Inspect the cabin filter annually or at every major service, and replace sooner in dusty or pollen-heavy environments. If your HVAC blows weaker than normal or smells musty, change the cabin filter and consider an evaporator inspection. Regular cabin filter replacement prevents this expensive cascade of HVAC failures and protects thousands of dollars worth of climate control components. But filters aren't the only invisible factor that affects every component in your vehicle. This reveals how invisible wheel alignment affects every single mile you drive. Your wheels look straight, your car drives reasonably well, but microscopic alignment errors create destruction you can't see. Every rotation of your tires fights against improper geometry, wearing components throughout your vehicle's suspension and steering systems. Misalignment creates intricate connections between seemingly unrelated failures. Tires wear unevenly, forcing you to replace them thousands of miles early. Ball joints work harder, compensating for incorrect wheel angles. Control arm bushings deteriorate faster under uneven loads. Steering components wear prematurely, fighting against improper tracking. Watch for warning signs. Steering wheel off-center when driving straight, uneven edge wear on tires, or the car pulling to one side. These symptoms tell you alignment problems already exist and damage accumulates with every mile. Check alignment whenever you rotate tires. Every oil change is a practical marker, roughly every 6,000 miles, and anytime you hit potholes or see uneven wear. 1 degree of misalignment destroys a set of tires in 20,000 miles instead of 60,000. Those same alignment issues stress suspension components beyond their design limits, triggering expensive repairs years ahead of schedule. Regular alignment saves tires and suspension components and prevents compounding failures that add up fast. But alignment isn't the only system where microscopic precision determines whether components last or fail catastrophically. The last habit centers on the engine timing system that operates with microsecond precision every moment your engine runs. If your engine uses a timing chain, treat the chain, tensioners, guides, and cam phasers as a single system that needs inspection and replacement as an assembly. These components must synchronize perfectly to prevent internal engine destruction while wearing gradually and maintaining critical valve and ignition timing relationships. Timing system components depend on each other completely. Stretched timing chains throw off cam timing. Worn tensioners allow chain slap that damages guides. Failed cam phasers disrupt variable valve timing systems. When one component fails, it destroys others in a cascade of expensive damage. Chains stretch and tensioners fail gradually. Replacing the entire assembly at an appropriate interval prevents catastrophic cascading failures. Timing system failure creates catastrophic internal engine damage. Pistons collide with valves at high RPM. Bent valves require cylinder head rebuilds. Damaged pistons need complete engine overhauls. These repairs often exceed vehicle values. Consider a proactive timing system overhaul around 150,000 miles, depending on engine design and how well oil was maintained. Replace timing chains, tensioners, guides, and cam phasers as complete assemblies when wear is apparent or around this suggested high mileage mark. Timing system maintenance ensures precise engine operation past 400,000 miles while preventing the most expensive internal engine repairs. These individual maintenance habits create their maximum impact when they work together as a complete system. The real power comes from taking action today instead of waiting for problems to develop. These 16 habits prevent expensive failures through consistent preventive maintenance that costs far less than reactive repairs. Start with 3 immediate steps. Check and change your oil and filter now, if overdue. Schedule a transmission drain and fill if you're past 60,000 miles, and create a maintenance log in your glove box or use a free app like Carfax Car Care, Drivo, or Simply Auto to track every service. If these tips helped you avoid expensive repairs, hit that like button and subscribe for more real-world maintenance advice. Drop a comment and tell me about the single worst repair bill you've ever faced. Prevention costs less and extends vehicle life far beyond manufacturer expectations. Follow that 3-step checklist and start protecting your investment today.